Okay, good morning students. Today we would like to start the session number 27. So in the present session we are mainly focusing on two things. One is the combined power plants and second one is the instrumentation and control systems. So in this topic we are right now we are in the unit 5. So in unit 5 combined power plant operation is the first topic here. So what is meant by combined power plants? So here we have a different types of power plants. As per our discussion in a unit 1 we are discussing about a steam power plant, unit 2 we are discussing about a diesel power plant and the gas turbine power plant. Coming to the unit 3 we are discussing about a hydro power plants, and unit 4 we are discussing about a nuclear power plants. So like this we are continuously studied the different types of a power generation processes. So all these processes are conventional methods, but the most of the cases we are seeing that the efficiency is very less. So for example, if you consider a steam power plant, the efficiency is around 27 to 35%. If you consider the diesel power plant, also the efficiency is around 30% only. So that means that we are utilizing a very less amount of energy and the wastage of amount of energy is very high. Okay, so the major loss of a wastage we need to reduce by using of a combination of a power plants. So here in the particular topic we are discussing about a combination of power plants. So what is the combination? How we can combine the one power plant with another power plant? So in this today's class we are clearly explaining each and every point. Okay, so coming to the introduction part. So the combined cycle is a characteristics of power producing engine or a plant. So here we need to study about how much amount of power is generated and based on the engine capacity or plant capacity. Okay, so more than one thermodynamic cycle we can apply. So generally we know that if it is a steam power plant, the steam power plant is operated by using of a Rankine cycle. Is it right? And if you run a gas turbine power plant, so the working fluid is the gas and this one is operated by using of a Brayton cycle. So here we are running the power plant with a Rankine cycle and the Brayton cycles. So the combination of different cycles we are running in a combined cycle power plants. So here more than one thermodynamic cycles we are following. Okay. So as per Brayton cycle, as you know, so in a Brayton cycle if you have a 4 thermodynamic processes, that is a constant heat addition process, adiabatic compression and expansion process, constant pressure, heat addition and the rejection processes. So different types of a thermodynamic cyclic processes are available, and here we are combining the different power plant with a different thermodynamic processes. Okay. For example, if you consider a heat engine, okay, it is able to transfer the energy, okay, some amount of energy, but the efficiency is less than a 50% only. Okay, the remaining heat from the combustion is generally wasted. So we are wasting the heat energy. So the main aim of a combined power plant is we need to utilize the heat energy in a proper way. Okay, so that is the main aim of a combined cycle power plant operation. Okay, and here combining 2 or more cycles such as Brayton cycle and Rankine cycle results improve the overall efficiency. If you see the content or result part, okay, so the efficiency is around 60% for a combined power plants. So generally you know that for a single type of a power station the maximum efficiency is around 30 to 35% only. So the remaining 65 to 70% of energy is wasted. Okay, but by using of a combined cycle power plant we are getting the 60% of efficiency. Okay, so later we can see where the combined power plants are operated, how the efficiency is improved. Okay, so coming to this so here see, this is a simple layout of how the energy is converted, how the energy is useful, how much amount of energy is wasted. Okay, so simply in our language it is known as the heat balance sheet or energy utilization. See, energy distribution in a combined power plant. How the energy is distributed. For example, if you give a 100% of fuel input, okay, so maybe that is a coal or a diesel power, diesel, any nuclear fuel, any fuel we are using. Okay, so the initial thing is efficiency of a input is 100%. How efficiently we are using, that is the matter. Okay, so this is the system here. The minor loss is the radiation losses. How much amount of energy is losses due to the radiation? That is only 0.5%. So 0.5% of energy is wasted due to the radiation losses, and output, so we are getting the efficiency around 38%. So we are gaining the energy output 38%. What about the remaining 62%? So 62% of energy we are wasted. Okay. So out of which 61.5, because the radiation losses are 0.5, so the energy wasted, energy in the exhaust gas is 61.5%. So I would like to utilize that 61.5% and we would like to generate the electricity from the wastage of electricity, from the wastage of exhaust gases. Okay, see here, that exhaust gases, okay, we are using for generating the steam. You are using for the generating of a steam. So here we are using the energy content is 21%. So 21% of heat energy is using to generate the steam power. Here also we have some losses. Here also same radiation losses are there. 0.2% of radiation losses are there, and at the condition of processing, that at that point also we have a radiation losses. Okay, and we are need to exhaust gases are leaving into the atmosphere, that is around 30%. But what about the remaining 30%? So the remaining 30% we are using for the condenser purpose in a condenser. So you know that the components of a steam power plant is turbine, condenser, feed pump, boiler. Here in place of a boiler we are using the direct exhaust gases. We are flow the exhaust gases on a boiler and we are generating the steam. That steam is flows on a turbine, and that turbine we are getting the steam content, and that is expanded condition. So that is also we need to convert into the liquid format by using of a condenser. So here we are wasted the 30% of energy, but the overall thing is we are usable energy is 38% plus 21% here. So total overall we are getting the 59% of efficiency. So this is our previous case we have discussed that efficiency of a combined power plant is around 60%. So these are the systematic division of a power utilization. Okay. So here we are getting the 21% efficiency without using any additional fuels. So the only fuel we are using in gas turbine power plant, that we are using again in a steam power plant. Okay. So this is the combination of gas turbine power plant with steam power plant. So this is the simple example how much amount of energy we are saving or how much amount of fuel we are utilizing in a proper way. Okay. So this is the simple layout of a energy distribution, and later I would like to discuss about a particular case where here we are seeing that line diagram of a gas turbine power plant and steam power plant. So see that if you know that in a gas turbine, so we have compressor, turbine and the combustion chamber. So these are the important components. For that what we need? We need the fresh air. So that fresh air is taken from the atmosphere and the compressor. So we are compressing the air. So that increases the pressure and temperature of the air. So what is the use of increasing the pressure and temperature? So once you are increasing the pressure and temperature, automatically it gives a proper combustion of a fuel, proper mixing with a fuel. Okay. So that's the reason we need to compress it. So that process is known as supercharging. Okay, supercharging gives a high pressure and that gives a proper combustion of a fuel. So here this is the combustion chamber and here we need to supply the fuel. So fuel also, you know that how the fuel is injected. Okay, so the fuel and the air is mixed in a proper way and here the proper stoichiometric air fuel ratio is formed and it creates the proper burning processes. So when the burning takes place here in a proper way, it releases the exhaust gases with a high temperature and pressure. So that exhaust gases are flowing on a turbine. So this is the turbine part. Okay, so this turbine is the gas turbine because the operating fluid in a gas turbine power plant is gas. In a operating fluid of a steam turbine power plant is steam. So fluid is important. Working fluid is very important. So in this working fluid is gas, exhaust gases. Okay, in a hydroelectric power plant, the working fluid is water. Okay, so like that, the working fluid is very important. So here, the exhaust gases are touches the turbine blades. Here the turbine blades are there. So that strikes with a high pressure steam. So automatically the turbine starts the rotating. So that means high kinetic energy is converted into the mechanical energy. So it's a turbine is a prime mover. It converts kinetic energy into the mechanical energy. So please remember these things. What are the components? Compressor, combustor, turbine. Compressor, combustor, turbine. So the compressor is compressed the air and it is sending to the air to the combustor, and here the fuel is entered in the combustor. So there the perfect mixing is completed and the combustion starts and it gives the exhaust gases with a high velocity, so high temperature, high pressure levels. So that kinetic energy, high kinetic energy is converted into mechanical energy by using of a prime mover, thermal prime mover. Okay, and here after the expansion process, what happened? So it has some temperatures. Because it's a high temperature and high pressure air, exhaust gases. So that gases have high temperatures. So that's why I don't want to release it into the atmosphere. So instead of releasing it into the atmosphere, we would like to utilize the exhaust gases for generating the steam by using of a steam generator. So this is the concept here. So this is the steam generator. Here we need to supply the water and that is converted into the steam format and excessive exhaust gases are released. So as per our energy discussion, so 10% of gases are stored, that means eliminated from the exhaust point. Okay, and here 21% of the energy is utilized. It's a rough calculation. Not exactly. If you want to improve the efficiency, you can consider the several parameters. Atmospheric conditions, you are using the fuel and the condition of a symbolic compressor and the fuel injectors, everything affects the efficiency of a entire thing. Okay? And later what happened? So the steam is flows on a turbine. So this is the steam turbine. So this is our steam turbine. So that is connected to a generator. Okay? So steam turbine is connected to a mechanical energy and that is connected to a generator. And here also one more component is there. So that is the condenser. Okay. So this is the cyclic diagram of a combined cycle power plant. A schematic diagram for a combined cycle power plant. So these are the working procedure of a combined cycle power plant. Okay, so if you understand that, what is the reason behind the combined power plant? How the operating principle is there? Okay, so the main aim of a combined power cycle is to improve the efficiency and perfect utilization of a fuel. The simple thing, perfect utilization of a fuel. Okay, and coming to the next thing, how the load variations are there. So our next topic. Okay, our next topic is load division between the power stations. Okay, so as per previous sessions, we know that what is meant by load. So the load means how much amount of power is required, how much amount of power is generated, okay. How the load is division between power stations. So in the present session we are discussing about combination of a power plants. So the combination of a power plants means we are using the two power plants. Okay. So here how the load is distributed. For example, if we have a capacity of 10 megawatt of a power plant, okay, if you required or if you generated 10 megawatt of a power plant, how we can utilize it in a single time, or some cases we are based on the power required, we are dividing the two power stations. So mainly we have two types of power load systems are there. One is the base load and second one is the peak load. So what is meant by a base load? So the base load means it's required in a mandatory condition throughout the day, throughout the month, throughout the year. So we need the minimum requirement of a power, so that is known as the base load. Okay, so that's an average power required for a day. But in case of a peak load, so the second term is peak load. So peak load means that is the maximum load at a particular time. So generally if you see in the daytime, if you see in a single day, the peak hours are generally some morning 10 to 12 or evening 5 to 7. So these timings are generally known as the peak hours. Why these are the peak hours? So in the morning session, every offices are opening, okay, administration offices are open. So that's the time we need to utilize the more power consumption. And the same thing, in the evening time, we are utilizing the more power in a domestic purpose. So like that, some peak hours are there. Okay. So that time only we are using a very high amount of power. So remaining time what we are doing, in a normal condition we are using in a normal way. So that's why entire day we require the minimum power. So that is known as the base load. And some particular times we need the maximum load. So that is known as the peak load conditions. Okay. So a simple thing, if you want to run the power in a continuously same power, so that is known as the base load. If you require a special power or high power in a particular times, that is known as the peak load. For example, for our college running purpose, so we need 1 megawatt of a power continuously. If you operate just 4 lights, 4 fans in your room, we don't utilize any additional power. Okay, for a regular class time purpose. But if you went for a laboratory, at that time if you need to switch on the AC or if you need to run the machines, so that means we are using the additional power. So at what time we are using the additional power? So only when we are running the operation of a experimental laboratory experiments. So at that time we require the high power. Maybe at that time we require the 1 megawatt. But so we are using the laboratory in a very less time only. Maybe 2 hours per day. 2 hours per day. So at that time only we required 2 megawatts. So the entire timing we required only 1 megawatt. So in this case, the base load is known as the 1 megawatt. The peak load is known as the 2 megawatt. So continuously we require 1 megawatt. At a particular time we require the 2 megawatts of power. So the minimum load required is the base load and the maximum load at a particular time is known as the peak load conditions. Okay. So how we can define or establish for a base load. Base load means we need to continuously operate the power plant. Peak load plant means we need to operate when we require the high amount of power or additional power is required. So at that time only we can run. Otherwise we need not to establish a power plant. So in this part we are mainly focusing on how the load is distributed between the power stations. So see here, it's a it's a common practice to serve to the lead load curve. Okay, so load curve also very important. So we are giving in a load curve, load versus time. Okay, so in a timing, so how much amount of power required here? In a timing, so if you want to draw a graph here, so see here, if you want to draw a graph, load, time, or otherwise if you consider load here and time here. So particular time, particularly we require some time, some power. Okay, so this is morning 12 o'clock, 3, 6, 9, 12. So this is a day timing. Okay, so at that time we require different loads at a different time. So this curve is known as the load curve. So the relation between load and the time required is known as the load curve. Curve is represents the relation between load and timing. So here the timing is start with the 0, 6 hours, 12 hours, 18 hours and 24 hours. And load requirement is 1 megawatt, 2 megawatts and 3 megawatts. So this is our load requirements. If you require 1 megawatt, that is known as the base load. If you require the 3 megawatts, that is the peak load. Okay? So generally when we require the peak load, so we require the normal load at a normal condition of, we require a normal load up to 10 o'clock. So this is for example 10. At 10 o'clock, I required 2 megawatts of power up to 12 o'clock. After that, I required again 1 megawatt. So this is a 1 megawatt power required in a day, midnight time. After 10 o'clock, after 10 am, I require the 2 megawatts. And again it fall back up to some time, that is around 17 hours. That means evening 5 o'clock. So at evening 5 o'clock, we required the maximum load, that is the 3 megawatts of power up to 7 or 9 o'clock, up to 21 hours. Later we require the same power. So see this. So here we can see the graph. Okay. So this graph explains that how much amount of power variations are there. So that means you need to establish a base load plan for a 1 megawatt. Because, so most of the time, how much hours? So here 10 hours and next 10 to 12 to 7 again plus 5 hours and 21 to 24 3 hours. So total 18 hours we required only 1 megawatt of power. When we required the high amount of power, we required only 2 hours of 2 megawatts, 3 hours, 3 megawatts. Okay? So that means we need to establish 2 power plants, and 1 power plant we need to run continuously, and another power plant we can utilize in a peak load timing only. So this type of power station is known as base load power station. Base load power station. When we require the excess power, so that power station is known as peak load power station. So that means you need to establish a base load with a 1 megawatt capacity and peak load with a 2 megawatt capacity. You can understand. Base load with a 1 megawatt capacity and peak load with a 2 megawatt capacity. The base load is continuously operating, but the peak load is operated when you require the additional time. Okay, when you require the additional time, then only we can run the power plant. That is also you can vary the load. If you run at a 1 megawatt capacity of a 2 megawatt power plant, that is based on the 50% load only. If you run with a 50% load, automatically it generates only 1 megawatt. If you run a maximum load, that is gives a 2 megawatt power output. So that is a load curve. This load curve we can generally establish. Now I would like to summarize the today's class. So in this today's class, we are mainly focusing on only few things. So what is the necessity of a combined power plants? What is meant by combined power plants? How it operated. So see here. So in this present session, we are mainly focusing on the terminology is combined power plant operation. So combined means combined power stations. So combined means if you add one or more station with each other. So we can add one power plant with another power plant or 1, 2, 3 like that. If you add any number of power plants. So combination of a power plant. Why it is required? Why it is required? So for utilizing the proper energy. So it is required for getting the proper utilization of a fuel. For proper utilization of a fuel. Otherwise what happens? So it causes to the wastage of a heat energy, wastage of a natural resources. So that's why we need to adapt it for a high efficiency optimum conditions. Okay. So what are the major things in a combined power plants? So in a general, if you consider a one power plant that is efficiency is around 30%, if you consider that combined state, you will get a 60% efficiency. So that means it doubles the efficiency. So the combined power plants are very useful to double the efficiency of a combined power plant. Power stations are utilizing fuels. So these are the reasons we are using the combined power plants. Okay. And coming to the next condition is load division in this part. So we have clearly discussed in this case how the load is division. What is the need to division? Okay. So load division is required to operate the power plant in a single stroke without losses. Okay. So these are the cases we are discussing here. Is it clear? Okay. Thank you. Okay. Thank you. So this class completed.